In this lecture, we're going to determine in code which units are visible for the player. How can we tell if another owner's unit is currently visible for us? Well, we can map that unit's current position to a pixel on the Fog of War render texture and check out that pixel's color. If it's mostly white, that means it's visible. If it's mostly black, that means it's not visible. This is the core of what we're going to implement in this lecture, so we can start doing things like hiding units in the fog in a future lecture. Let's start in VS Code. In our Explorer, in our scripts player folder, let's make a new script called Fog Visibility Manager. Let's put that in the namespace GameDevTV RTS player and make it a public class Fog Visibility Manager. That is a mono behavior. Let's make this require a component type of camera, and we'll get a reference to that on awake. So let's define a private camera, Fog of War camera, and a private void awake, Fog of War camera equals get component camera. Remember that we're going to map units' positions to our render texture. We can't directly read a render texture. We have to convert it to a texture 2D first, which is a little bit of a hassle, but that's what we have to do. Let's do a private texture 2D vision texture. And the process for reading this also requires that we have a rect. So let's define a private rect, texture rect. Then in on awake, after we've gotten our Fog of War camera, we want to initialize our vision texture in our texture rect to the size of our Fog of War camera's current target texture. That's just vision texture equals new texture 2D, Fog of War camera.target texture.width, Fog of War camera.target texture.height. And then for the rect, texture rect equals a new rect with a 0, 0, XY offset, and just the vision texture width and the vision texture height. Now that we've set up our texture in our rect, let's define the function of private void read pixels to vision texture. And in here, we're going to want to read the values from our Fog of War camera target texture. This is effectively copying the data from our render texture into this texture 2D. This is important because we can't directly read a render texture's pixel values. They need to be in a texture 2D. The process for doing this is outlined on the Unity documentation. So we're going to do exactly this. We just store our previous render texture with render texture, previous render texture equals render texture.active. Then we want to assign the current render texture active to our Fog of War camera.target texture. What this does is we stored whatever we were previously rendering to, then we've overridden render texture.active to be whatever our Fog of War camera is, which is our active visibility. Then we can do vision texture.read pixels, providing that texture rect and saying a 0, 0 offset. That's telling it to read the entire texture. Because we don't know where our units are going to be, we need that whole texture, and then we can sample arbitrary pixels on this texture. Then we set the render texture active back to whatever it was doing before. Anytime we want to read a render texture, this is the process we want to do. Store the previous render texture, override render texture active to whatever our render texture is, and then read those pixels into a texture 2D, in this case, our vision texture. Then restore our render texture active to whatever it was doing before. Now, once we have this data in our vision texture, we can define a private void set unit visibility status that accepts an abstract commandable. And this is the function we're going to call for every alive unit that we do not own, and we want to set up, is this thing visible or not? First, we want to convert the commandable's position to a point on our vision texture. Unity has something built in for this, where we can define a vector3 screen point equals our Fog of War camera.world to screen point, providing the commandable transform position. That converts our commandable current position to a point on this render texture. Then we can just read the color from the vision texture at that point with color visibility color equals vision texture.getPixel, and then just typecasting our floats to ints with int screenpoint.x, int screenpoint.y. That just samples a specific pixel on that texture and gives us the color of it. Then we can debug.log, a template string determined that the commandable name is. Then we can check the R value of the visibility color at this point is greater than 0.9. If it is, we're going to say it's visible. If it's not, we're going to say it's not visible. So now we've got the two critical pieces of how can we determine where a particular unit is and get that color of that pixel. We want to do this then on late update, so all unit instantiation and movement is guaranteed to already have happened. We'll first read the pixels to the vision texture, and then we want to go for each abstract commandable in some collection of alive not owned units, and we want to set the unit visibility status for this commandable. Now I've got all the core functionality in place. My challenge to you is to, in this new Fog of War Visibility Manager, maintain a collection of currently alive units, exclude buildings for now, that the owner player 1 does not own, and call it alive not owned units. So pause the video, make the Fog Visibility Manager aware of all of the alive units that are not owned by player 1, and I'll see you back here in a few minutes. All right, welcome back. Now we've done this multiple times before. I hope you're able to get this one. Up here at the top, maybe after our camera and texture 2D stuff, we can define a private hash set of type abstract commandable called alive not owned units and set that to be a new hash set with, and I'm going to give a default capacity of 1000. So hopefully we don't resize this very frequently. Then on awake, we want to do bus of type unit spawn event dot register for all handle unit spawn. Then a bus of type unit death event dot register for all handle unit death. And before we implement those, let's practice good hygiene and do private void on destroy and unregister for these. We can copy paste our register for all and just change them to .unregister for all on both of those. If we scroll down to the bottom, we can define a private void handle unit spawn that accepts a unit spawn event EVT. And let's also define that private void handle unit death that accepts the unit death event EVT. And on that second one, we can do alive not owned units .remove EVT unit. On handle unit spawn, we want to first check if EVT.unit.owner is not equal to owner player 1, and we can do alive not owned units .add EVT unit in here. And that's all we were looking for in this challenge. Another acceptable alternative would be if you subscribe to all event channels except owner player 1. I personally find that to be very verbose, so that's why I went with this solution where we just filter out owner player 1 events. If you did subscribe to each owner except owner player 1, that's totally fine as well. You might have wanted to do something like read the pixels to the vision texture and set the unit visibility status in here, but because we're doing this on late update, that will automatically be captured on the same frame. If we come into Unity, we can see this in action. We just have to come up here and find the Fog of War visibility camera, the one that's outputting to Fog of War render texture. We can just attach the Fog Visibility Manager to this camera, and then let's find this air transport. And let's give them the owner of AI1. And then let's just move them out of sight of everybody else. If we click play, if I just pause, we see a lot of logs came in. We're seeing a lot of units are not visible, which is perfect because we cannot see any enemy units. We can only see our own units, and we're not seeing any logs about our own units being visible. In the hierarchy, we can select all of our base defense groups and delete them. We can start seeing only the air transport is not visible is being logged. If we then take a rifleman and move them in here, we start seeing that new log that the unit is visible. Let me get rid of the collapse so we can see them coming in real time. And once we leave, boop, they switch over and is not visible. Now we can still see that unit, but at least we have a script now, Fog Visibility Manager, that can tell us that we should not be able to see that unit. In the next lecture, we're going to handle making it where we can actually not see that unit anymore, so the player will have no idea that there's a unit there anymore. When you're ready for that, I'll see you on the next lecture.